All right, today we're going to go back into solving systems of equations just to get you guys used to doing these again. We're going to do a nice warm-up. So my recommendation is that before you go any farther, you pause the video and try and solve this on your own before watching me do it. So go ahead and pause now and copy the problem down and work this out. All right. Now that you've worked this out and you should hopefully have an answer, I'm going to work it out for you. So the first thing that we're going to want to do is decide on what method we're going to use. I tend to lean towards elimination a lot more for the simple fact that some of these, especially in particular with this case, you're going to work with fractions, and I know how much you guys love those. So to eliminate those fractions, I'm going to use the elimination method. Here, it doesn't really matter whether you choose to eliminate x or y. It actually ends up becoming about the exact same thing. It just depends on what you're going to multiply by. I'm going to choose the x's. So I look at my x's and I say, well, I have 3 and 2. Well, 2 doesn't go into 3 and 3 doesn't go into 2 evenly. So what I can do is I can find a number that they both go into. 6 would be a good number. So to get this 3x to go to 6, I need to multiply by 2. So down here, I'm going to get 6x. Remember, I distribute through this entire equation, so you're going to get 6x plus 4y is going to be equal to 24. Now, I need to get this 2x to be a 6, but remember, if I'm going to use my elimination method, I need to have opposite signs. So instead of just multiplying by a 3 to get that 2x to go to a 6x, I'm going to multiply by a negative 3. You're going to get negative 6x plus 9y is going to be equal to negative 63. And now that I have same numbers, opposite signs, we can go ahead and we just add those two together. So my x's are gone. I get that 13y is going to be equal to negative 39. Divide both sides by 13. I get that y is equal to negative 3. And I go back into one of my equations, doesn't really matter which, and I plug this y value back in. I am going to choose the first equation, really for no particular reason, other than I know I'm going to divide by 2 at the end. So, but you could pick the second equation if you would like. When I plug this back in, I get 3x plus 2 times negative 3 is equal to 12. I get that 3x minus 6 is equal to 12. Add this 6 over. I get that 3x is 18. And I divide by 3 on both sides. I get that x is going to be equal to 6. Remember, when you're doing systems of equations, we're looking for where those lines intersect, so that's going to be a point. So you have to write your final answer as an ordered pair. 6, negative 3 will be your answer. If you chose to eliminate your y's, you would have gotten the same answer as long as you, of course, did all your math correct. If you did the substitution method, then you should end up with this result as well. Today, what we're going to try and do is we're going to take it a step farther. Now, instead of having 2 variables, x and y, now I'm going to add that third one in there, z. These tend to be a little longer, but I don't think they really seem to be conceptually much harder. One thing that I have found is that if I label my equations, that tends to help me out a lot. So I always just label the first one A, second one B, and the third one C. And you guys will see here in a second why I do that. If I look at particularly A and B, so far I've only talked to you guys about solving systems of equations with two variables, x and y. Even if I called that y a z, it would still follow the same process. So what we want to do is we want to somehow combine two of our equations to eliminate one of our variables. Well, I see that I have my y's in equations A and B. They already have opposite signs, and in equation B, y has a coefficient of 1. It's already by itself. So that would be pretty easy for me to manipulate that to eliminate my y's. So what I'm going to do is I'm going to have A, and to eliminate my y's, I need to get a 2 in B. So I'm going to add that to 2 times equation B. So I'm going to add that there. And the reason I'm going to do that is I'm going to eliminate y. So my problem now becomes 6x, excuse me, A stays the same, 3x plus 2y plus 4z. Just a side note, I cross my z's so I don't get them mixed up with 2's. And that's going to be still equal to 11. Again, I distribute this 2 in equation B to everything, so I'm going to end up with 4x minus 2y plus 6z is going to be equal to 8. Now, just like in my elimination process before, I just go ahead and I add everything together. So 3x plus 4x is going to give me 7x. My y's are gone. I get plus 10z, and that's going to be equal to 19. And I'm going to call that equation D. Now, I know it doesn't seem like that's helped us out much, but it really has. Now, I need to somehow bring equation C into this whole problem. So what I'm going to do is I'm going to use either equation A or equation B because I've already used both of those together. And I want to eliminate y's again. The key here is you want to eliminate the same thing. So depending on how your problem is set up, you could eliminate your x's, you could eliminate your z's, or in this case, you're going to eliminate your y's. So I'm going to get rid of this 2 here from equation B. And now I notice that y, again, is very easy to manipulate so that I can get that. I have y and 3y. They're both negative. So if I multiply equation B by -3, then I should get same number, opposite signs. So I'm going to take -3b plus equation C to eliminate y. When I multiply equation B by -3, I am going to get -6x plus 3y minus 9z, and that is going to be equal to -12. Okay, I've just multiplied that through, and I double check equation C. I don't change that, so I just copy that down into my problem. I add that to 5x minus 3y plus 5z equal to -1. I add these. Again, straight up and down, just like I did before. -6x plus 5x is going to give me a -x. Y's again are gone, and I get -4z is equal to negative 13. I'm going to call this equation E. So now what I have is I have two new equations, D and E. So just to rewrite those out together, I'm going to get 7x plus 10z is equal to 19, and negative x minus 4z is equal to negative 13. Now, I can do substitution elimination here. I think elimination is probably going to be the way to go. So I'm going to take, I'll label these again just so we're on the same page. I'm going to take D, and it looks like it would be pretty easy to eliminate my x's. So I'm going to add that to 7 times equation E. Multiply that there. So my problem becomes 7x plus 10z equals 19. Equation E becomes negative 7x minus 28z, and that's going to equal negative 91. Add these up. I get that negative 18z is equal to negative 72. Divide both sides by negative 18. And I get that z is going to be equal to 4. Now, just like before, I've got my z now. So I'm going to go up to either equation D or equation E, and now I can get my x. So this is what's called back substitution. So I'm going to take my z, plug that back in. I'm going to plug it into E just because I've got x almost by itself. So I end up with negative x minus 4 times 4, and that's going to equal negative 13. Negative x minus 16 is negative 13. Add 16 to both sides. I get that negative x is equal to 3. So that means x has to be negative 3. You can either multiply or divide by negative 1. Now that I have x and z, I can go all the way back up to equation A, B, or C. In this case, I am going to pick equation B because I know I'm looking for y. So I'm going to plug into that. I'm going to get 2 times negative 3 minus y plus 3 times 4. And that has to equal 4. Simplify this a little bit. Negative 6 minus y plus 12 has to equal 4, or negative 6 plus 12 is going to give me positive 6 minus y equals 4. Subtract my 6. I get negative y equals negative 2. So that means y is going to be positive 2. Now, just like before, this is going to be a specific point of intersection. Now we have added in a z component. So instead of just being flat on your piece of paper, it's actually going to be 3-dimensional. So instead of writing an ordered pair, I now have 3 that I need to write. So you are going to write what is called an ordered triple. Your ordered triple is going to go x, y, z. So because I've just tacked a z onto the end of our problems that we've been doing before, now I just tack it on in my ordered triple. So I write it just like I did before, -3, 2, and 4. And that is how you are going to solve these. All right. I got one more example for you guys. Again, it's following that same process. You want to eliminate the same variable either in equations A, B, or through equations A, B, and C. I'm going to call the first one A, second one B, third one C, just like I always have. This is not something that you need to do, but I've had people in the past tell me that that seems to help them quite a bit, just to help everything organized, keep everything organized. As you guys saw in the last example, there's quite a few moving parts to this process, so being able to just say A and B tends to help them. In this one, I look for what could I easily eliminate. Well, in A and B, it looks like my y's already have the same number, opposite signs. They're both y. One's negative, one's positive. Negative in A, positive in B. So, since I already have my y's by themselves in A and B, let's eliminate those right away. So, I'm going to take A plus B to eliminate y. You don't always have to eliminate y first. That's just how these problems seem to work out for us. So, like I said in the last example, you could do x's if that works easier. You could do z's if that works easier. These two examples, it just happened that y was the easiest to eliminate. Since I haven't manipulated a and b, I take 2x minus y plus 2z. Again, here's where crossing my z's comes in, so it doesn't look like 22. And that's still going to equal 15. And I take negative x plus y plus z. That's going to equal 3. Add those two together. I'm going to get that x, y's are gone, plus 3z is equal to 18. All right. So I've already got one variable down. I'm going to call this equation D. So I look at either A and C or B and C. And I notice if I use B and C, again, I end up in that same situation where I've already got my y's with opposite signs, same number, so I can just add them. I could use A and C if I wanted to. Again, it just depends on what's easiest for you in the context of your problem. So now I'm going to add B plus C to eliminate y. So I end up with negative x plus y plus z is equal to 3, and 3x minus y plus 2z is equal to 18. Add these up right away. I get negative x plus 3x is going to leave me with 2x. Y's are gone. My z's, z plus 2z, is going to leave me with 3z. And 3 and 18 add to 21. Again, I'm going to call that equation E. You guys can really call these equations whatever you want. I just think letters are a little easier to work with than anything else. So now I've got my system of equations that we've worked with in the past. X plus 3z is equal to 18, and 2x plus 3z is equal to 21. Now, this sets up really nice for elimination because I already have the same number in front of my z's. The only thing that I don't have is my opposite signs. So I am going to multiply e by -1. All that's going to do is change those signs. So I'm going to get negative x minus 3z is equal to -18. And 2x minus x is going to leave me with x. 18. 21 plus -18 is going to leave me with 3. And I've already solved for x. Now, I'm going to plug that in to either D or E. I'm probably going to choose D, that top equation, just because I don't have to do some multiplication there. So that is coming back up into that equation. I end up with 3 plus 3z is equal to 18. Subtract 3 from both sides. I get that 3z is going to be 15. Divide by 3. I get that z is 5. And then, now since I've got x and z, I can go back into either one of my first equations. Again, make this easy on yourself. I know what x and z are. I need to solve for y. B looks to me to be the easiest because I don't have any coefficients that need to be multiplied other than 1. So if I plug into B, I get that -3, because my x value is 3, plus y plus 5 has to equal 3. Y plus 2, -3 and 5 give me 2, and that's still equal to 3. Subtract my 2, and I get that y is equal to 1. Again, write that in your ordered triple, and we're done. So x is going to be 3, y is going to be 1, and z is going to be 5. Oh, 5, not z. There's our answer. We'll get a lot of practice with these this week. Hopefully give you some time in class tomorrow to work on these. So give these 3 a try for tonight. Let me know if you have questions. I'll be more than happy to work through these with you and answer any questions that you have. I will warn you guys, a lot of the mistakes that I see with these are not the big idea of the concept of trying to do these. It's the small addition and multiplication errors that'll get you. So pay special attention to those, and hopefully that will fix a lot of problems that you guys have. So if you have questions, let me know. Other than that, give these a try, and we will check these in class tomorrow.